Hello, Year 8. It's just, one of my last videos. I'll make a couple more on the last topic, evaporation and radiation. So we'll look at evaporation and how energy can be transferred by evaporation, right? So that's your title, evaporation first. And we're going to look at how we cool down by evaporation. Now, we know that you cool down very quickly if you stand around while you're wet. Okay, so much more so than when you're dry. Now, why is this? Well, we cool down because some of that water is evaporating off the surface of our skin. And this is how sweat glands work, right? So when you play football or any time outside, especially in this country, your sweat glands are going mad. They're pushing liquid out onto the water, out onto the surface of the skin. This water then evaporates and transfers heat away. So how does this happen? Well, if we check out this diagram, this particle model here, the dark red indicate particles with much more energy than the light red particles. So we can see here, as you sweat, the water has lots of energy in it. After evaporation has taken place, all those high energy particles have escaped. They're no longer a liquid anymore, they're a gas. So actually, when that happens, energy is taken away from that liquid, right? A really good way to sort of illustrate this diagram here. Let's make it a bit bigger. Okay, so children and money. So we've done this one before. So if we count it up, this is the sweat, the liquid that we've just sweated onto the surface of the body here, right? If we counted that up, 200 pence or 200 baht, let's say, right? Now, if we wanted, if that water was to evaporate, it would be the higher energy particles that did so first. So this person here has got 16 baht, 15 baht, 17 baht. Anything over 15 pence or 15 baht will evaporate and will leave the liquid. So now instead of having 200 pence in the room, with an average of 10 pence per child, we now have, because those kids, or those high energy particles, high energy particles have now left, yeah? We've got 152 pence or baht in the room, between 17 children now, so the average money or average energy per child has actually now decreased to 8.9 pence. So if we say, instead of saying the average energy, we say the average, instead of saying the average money per child, we say the average energy, average kinetic energy has now dropped. Yeah. We can say the temperature has also dropped, because that's what temperature is, isn't it? It's the average kinetic energy per particle. That's what temperature is. So this is how evaporation works. You sweat, the high energy particles leave, evaporate, and they take all that energy with them, so your temperature drops. And this is how we cool, by sweating. Plants also do it because they evaporate water out of the pores in their leaves, and that actually cools them down as well. Okay. All right, so moving on now to radiation. So radiation is another way that heat can be transferred. And this is a bit different from convection, conduction and evaporation, because this doesn't require any particles at all. Radiation is in fact just an electromagnetic wave, and we can see these images here that I'm showing you. Here's a cow. We use an infrared imaging camera to see infrared rays, and you can see actually some parts of the cow emit more infrared radiation or heat than other parts. Okay, so Here's a house. Now, some parts are emitting much more radiation. The windows are not keeping the heat in properly, but we can see the roof is probably keeping more heat in. And this is the way the military use infrared rays so that they can see at night. Okay, there's another number of different images here. Okay, so if you were to look at yourself, the hair on your head stops infrared being lost, but your skin really gives off quite a lot of heat. But your clothing stops the infrared from leaving. Okay, so how does this work? What would be really good for your notes? Now, infrared radiation heats objects up that absorb it. So heat radiation comes from, well, it comes a lot from the sun. Yeah, so that's our main source of infrared radiation. And the best absorbing surface is black. So if you were to wear a black top and you go out into the sun, you probably notice this patina when you wear your dark top and your white top. And the white top reflects it, and the black top actually absorbs it. You get hotter if you wear your black or dark blue top. Okay, so this is really good for your notes. I think this should be something you have in your notes. Shiny surfaces do not absorb either. In the same way, black surfaces absorb infrared radiation. They also give it out the best. So darker surfaces actually re-emit infrared radiation much better than white or silver or shiny materials do. So that's why the inside or the outside of your thermos flask or your water bottle is probably going to be silver or shiny to stop it from emitting infrared radiation. Okay, so emitters, there you go, there's a diagram for your notes, and that one as well. You might be able to combine those two diagrams into one. Good emitters, also good absorbers. Poor emitters, also poor absorbers.